RBS Busy Research Academy welcomes to you in the lecture number 39. In this lecture number 39, we are going to understand how to perform NCA, Necessary Condition Analysis in SmartPLS. So before this one, we were performing the necessary analysis in the R software. What we were doing is that we were importing the latent variable score from the SmartPLS to the R software, and then in the R software we are applying the NCA over. So now NCA we can also apply in the SmartPLS. Therefore, there is no need to go to import your latent variable score in the R. So how we can apply the necessary condition analysis? So this video is going to teach you. So in this regard, I suggest you, so please watch the video lecture number 38, which is completely a theoretical video on NCA, and then come here. Then I hope then you will be sufficiently able to understand different concepts which we are going to discuss in this practical video. So before starting this video formally, I would like to introduce myself. My name is Dr. Rahim Sumro, and I'm working as a professor at the Institute of Business Administration, Shahwati University, Pakistan. So in this video, NCA. So there are the 6 steps are there of the NCA, and stepwise we are going to understand the NCA. So first step we are looking here. So this step talks about the specify the research objective and the theoretical background. So here you have to find out some theoretical reasons why you are going to apply the necessary condition analysis, and along with the theoretical justification you have also show the some research objectives. And then another thing is step number 2, which are looking right now. In the step number 2, what we have to check the prepare and the check data. In prepare and the check data, what we have to look for? Sample size. So first of all, sample size we have to look. So now there should be this ample sample size. So in this regard, if you see the here, our sample size is the 384, which is quite sufficient like the sample size to apply NCA. And then next thing is about the distribution outlier, and then we have to check about the measurement level coding on all these things. So these things you can check here. So in this one, all the options are descriptive is available here. Descriptive, mean, mode, median, all these things are from there. The step number 2 can be completed. And then if we talk about the step number 3, so step number 3 talks about the run the PLS-SEM analysis on the data. So now what it will provide when you run the PLS-SEM analysis, it will provide the latent variable score and the structural model relationship. So now we are going to apply. How to apply? That's very easy. Go to calculate and then choose the PLS algorithm, and then just start the calculation, because by default setting is okay. So we have run the PLS-SEM analysis. So where we are going first, we are going to check the measurement model, because we talk about the PLS-SEM. There are the 2 of the model are there. There the measurement model and the structural model. First, we have to check the measurement model, and then we will check about the structural model. So one more thing which I want to say, there is a like here. Now these are our reflective constructs. So now the other type of the construct is a formative. So if you want to know the difference between the reflective and formative, then my video is available. Image of the video there means 2 videos are available. Images of these 2 videos you are looking here. So if you want to know about the difference between the reflective and formative, I suggest you to go through these one. Okay. So now what we have to check in the measurement model. So we have to check about the path coefficients are there. So these are the impact of interval scale on the interval performance. So interval performance, and here is also entrepreneurial performance, but entrepreneurial performance is our dependent variable. So there's why means that horizontally and vertically in this matrix you are looking in the same path. So that's why nothing is there. Otherwise, all the impacts are here. And then if we talk about the quality criteria, R square is okay, and the F square are also okay. Some of the effect size are they means a 0, but again Then we have to check the construct reliability. There is no issue of the current valve for composed reliability in the AV. All are in the green color. Whenever there is a value which is in the red color, so there is one problem. But hopefully, there's no problem so far in our data analysis. If we talk about discriminability, again, all are in the green color, no problem. And a collinearity diagnosis, if we talk about the variance inflation factor, so some except two issues are there. Otherwise, generally we can say that there is no any problem in the data. So structural model wise, the data has no any problem. And now, what we to check is a reflective, and we check the evolute the loading, we check the Cronbach alpha composed reliability, average AVE heterotrade monotrade, and because all our construct are reflective, so that's why we have looked for all these one, and we come to know that means that is at least there's no problem of the whatever the criterion which we have mentioned over here. So as you know, in the step number 5, you're looking here that we have to transfer the latent variable score. So here we have to find the latent variable score. So latent variable score is located here. This is the latent variable. Double click it, and now the latent variable score of the all our 5 latent variable is available here. So you are looking, if you go down, then here you're looking at our total sample size is 383. So now the latent variable score of the each item, each item as well as the score of the every respondent is available here. So now how to import this one? So just very easy. Just create the data file and then uncheck this manifest and just check the latent variable score, because we are interested only in the latent variable score. And so what was happening earlier when the necessary condition analysis was not available in the SmartPLS, this score we were importing from the SmartPLS to the R software. But there is no need. Now we have to, first we have to create the latent variable score. Just please click OK. And then now go back, and the latent variable score has been created. So now you look at, this is the latent variable score. NCA trial project derived from the latent from the PLS result. So, but before applying the NCA, we it is required to go through the step number 6. In the step number 6, now we have to apply the NCA. Use the R package, but we will not use the R package, but because the same package is available in the SmartPLS. So now here the default setting are the 10,000 permutations. So now we will apply the 10,000 permutation. Permutation means here, that means whenever we want to test the structural model, we are applying bootstrapping technique, bootstrapping algorithm to check either our impact are significant or not. In the same way, the permutation also works same over here. So in this regard, you're looking, that means what we have to apply NCA. Trial project, like it is a name of our file, okay, and then we have to apply the regression, okay. Save, and then what we have to bring here, first of all, our dependent variable. Our dependent variable is interval performance. Our independent variable is just select and drag it and leave it here. So now the first one related is interval skill, and then other 3 are there. So again, do the same job with these 3 one, and now we have the 4 independent variable and the 1 dependent variable. So now the name of all these dependent variable, all these variable is long. So we have to shorten this one. So in this regard, you can remove the unnecessary name, means the term of the detail from the name. So one by one we have to do. Just you can. Okay, you can do all this one, just a rename you can do. Okay, and then press that this one has been in. So now these 2 methods are either you can go through this one and in this method apply, or you can select the rename. The same thing you can do by through this technique also. These are the cells orientation. Okay, and then lastly we have to do the same thing with this one, edit setting, and then independent skills. Okay, so now all our names of the different variables have been shortened, and now we have to apply the NCA. How to apply the NCA? Very easy. Just go in the standard algorithm. So there are the 4 standard algorithms are there. So now first one is a regression analysis. We are not interested right now in the regression analysis, but my one video is available on the regression analysis. Now, if you if you are interested in this one, my this image you are showing here of that video, you can go through over there. The next one is a logistic regression. So, but here we are interested in the necessary condition analysis. Just click it, and then you're looking here. So now the necessary condition analysis is a data analysis technique identify the necessary but not sufficient condition in the data set. So now if you are interested more, then you can click it, the more information, and it will guide you a new like the web page will appear, and this will provide you more detail regarding the NCA. Number of the steps for bottleneck table. So now here a bottleneck table will be created with the 10 columns. If you want to increase the column, you can also like the increase the number from 10 to 15 or 20, whatever you. But I think that means 10 is okay. So just start calculations, and then our like all the tables are here. So the first thing is about the graphical output. You are looking here that the impact of all these are given here. Like the impact of the interpret skill on the interpret performance is 6%. Interpret impact of the market orientation is a 4%. Impact of network is a substantial impact. That's about the 32%. While sales orientation has no impact, and along with this one, it is also a negative relationship with the negative impact on the interpret performance. So furthermore, here ceiling line effects are there. So here you're looking at the these are our variable, and this is the CE-FDH, which means that the ceiling envelopment free disposable hull, and the ACR, that's about the ceiling regression free disposable hull. So that's the impact of these all these one, and other details are there like the ceiling lines. So here these are effect size are there. As already I told you that the network has effect size, substantial effect size is there. So now if we talk about the effect size, there are the 4 criteria are there according to the hull. So now if the value of the effect size is more than 0 and up to that 0.1, alternatively we can say the 10%, it is small effect, but at least effect should be more than 0. So now and another criterion is that if the effect is from the 0.1 to 0.3, it is a we can say that the small effect, and if it is more than 0.3 to 0.5, it's a large effect, and if the effect is a more than 0.5, it's a very large effect. So now the network is sharing in a large effect like the effect size, while the interpret skill and the market orientation, they have a small effect on the like the on our dependent variable, while the cell orientation has no effect. So now you're looking at these are the corner tables. So the corner tables of the every like the 4 independent variables are there. Networking, market orientation, that means the impact of the each item on the IV on the each item of the DV. And then bottleneck table is there. This table shows now these are the bottleneck table. So here looking, there are the 10 columns are there. Already means when we were giving the value of the bottleneck at a time, I told you that if you increase from the 10 to 20, you can also increase the column, but we gave the 10 over there. That's why we have the 10 columns over here. So now this is our Z score. So we are not interested in the Z score, but we are interested in the percentage. So here this is our percentage score, which shows that if you want to have the 80% of the interpret performance, 0.81. So now that means that you are required nothing. The interpret skill is not necessary, but market orientation value is a 0.08, and the networking is a 3.065. So if you want to get the 100% interpret performance, then you are required the interpret skill 44% and the market orientation 7.55, while the networking you require 27.808. While it says orientation all the way, you are looking zero. That means a zero contribution, because I showed you. That means that this has a negative impact. Like you looking here says orientation is negative impact. So that's why it's not giving you any like the values of the effect size. So here there are the charts. So as we have the 4 IVs, so now for each IV you are looking here, the necessary condition analysis charts are there. So now this is our regression line is there. You're looking regression line, and this is our enrollment line. You're looking here, and this is our observations are there. All 383 observations you are looking here. Okay, so if you want to customize this chart, the customization available option is also available to you. Okay, so now the last thing is that we want to check about their significant. Either those are significant or not. It is very easy. This time we have to go into the NCA permutation. So in the NCA permutation, now this permutation algorithm allows you to determine the statistical significance of the necessary effect size D from the necessary analysis. So effect size, the symbol of effect size is a D. And then what NC permutation does, it does only that the check the either our effect size is statistically significant or not. So for this purpose, normally people are applying that 5,000, but it's good to apply the 10,000 permutation. And this is a do parallel processing. What it does, basically, it starts the two type of the processors in your computing machine, and both will generate a different subsample, and then they will then they will be compared, and then the result will be given to you. So significance level is the 0.05. Normally we follow the 95% confidence interval. Fixed seed is okay. And then start calculations. It's very quick to calculate all these things, and now we have got the results. So results of you're looking here, the impact of the input skill is like the small effect 0.6%, and again it's now we can say not significant. The impact of networking is that is significant. Market orientation, impact of networking 32%, that is also significant, while the impact of cell orientation is not significant. So these are our results are there. Okay, so now we are going to understand these results, what these results are saying. How to understand? We are going to open Excel file. Now here Excel file is there. So in order to understand the results of the NCA, there are the three scenarios are there. One scenario is an exogenous construct. Is exogenous means the independent variable where the PLS-SEM results are there. Significant determinant. Okay, and then also in the NCA result, it is also necessary condition. Then we have to interpret the result in this way. And then if our exogenous construct is significant but not necessary, then we have to interpret the result in this way. And also our exogenous value is non-significant but it's a necessary condition, then we have to interpret in this way. How to interpret? Now this like Excel file is there. So now first we have to put the PLS-SEM results. We're looking, these are the PLS-SEM results are there. And then we have to put NCA results. So these are our NCA results. So, and now this table, orange table I have brought, this is the orange table, while this is another table is there like this one, like the green table. So now green table I got from the, I applied, okay, yes. And then when I applied NC trial project, and then I applied PLS algorithm, okay, not PLS algorithm, but when I applied bootstrapping. So now bootstrapping when applied, then I received some of the tables from here. So now this is our table path coefficient. So this is a table which I copied from copy to Excel, and then I pasted over here. In order to save our time, I already did this thing for you. So now three scenarios are there. First scenario is our data significant and the necessary condition. So first thing is about the effect size and impact of the interpretive skill on the performance. Now it is a 30.37 and it is also a significant. Okay, so now first condition has been fulfilled. There is a PLS as result same is a determinant is a significant, and another condition is that p value of the intermediate scale is also it's not significant. That means we have to go check this condition, because this value is more than 0.05. So that's why we have to go through this one, that the exogenous construct is significant, but it's not a necessary condition. Why? Because its permutation value is more than 0.05. It means that statistically it is insignificant. So now how we can interpret? It's very easy. On an average, first of all, on an average, an increase in exogenous construct means that independent variable. Independent variable here is our entrepreneur skills. That means the exogenous construct will increase outcome. Definitely it will increase outcome, but no level of the construct. Like we can say bottleneck table is not required here. So but the bottleneck table is not required here, because there is no minimum level of this construct. And then another is about our market orientation, and now it is insignificant, and here it is significant. Okay, but its effect size is just 4. But again, this falls here. In this scenario, third scenario, it means that the non-significant determinant, it means that our market orientation according to the p-value is not significant, but according to the necessary, but it is necessary condition, because its permutation value is less than 0.04. How we can describe the result? We can say a certain level NCA bottleneck table of the exogenous construct is necessary for the outcome to manifest. So now certain level of the outcome is necessary for this exogenous construct. However, further increase is not recommended, as it will not increase the outcome. So it will not increase. So further there is no need. But the last thing is about the entrepreneur network and the performance. It is substantial effect. It will also statistically significant in case of the SmartPLS results, and also significant in case of the NCA. 32% are the large effect of the effect size is there on the means are our independent variable. So how we can interpret it now? This, like the networking, falls on the first scenario. So first scenario is our significant determinant. So here it is a significant. A necessary condition is also significant. So necessary condition is also so now this network is the only factor which meets the requirement of the first scenario, where our independent variable not only significant but also a necessary condition. How a necessary condition? Because its value is more than is less than 0.05 permutation value. We can say statistically it is significant. And now how to interpret now this on an average, an increased exogenous construct will increase outcome. So now it means if you will increase the networking means it is our exogenous, it is same level our endogenous means our interval performance will also increase. However, it is certain level. It will increase. Beyond this level, it will not increase. It will not contribute anything. At what level? How to know that level? So now we're looking. The bottleneck table is available. In the help of the bottleneck table, you can check out at what level it can help you to increase the our endogenous variable. So now my video lecture number 38 is available. So now I suggest you to go through that video. In this way, you can be able to understand the bottleneck concept, and you can also understand the how we can interpret these three scenarios by referring the bottleneck table. So at the end, thank you very much for watching this video. I hope this video has cleared all the concept regarding the necessary condition analysis. So ultimately, or generally, we can say that we have checked the effect size of the 4 independent variable on the independent performance, but the networking was the only variable which has a large effect of the 0.36 on the our dependent variable interval performance. So that's why we can say that if you want to enhance the interval performance, the network is a necessary like the independent variable. So thank you very much again for watching this up to the end.